find the value of s square root of 2 plus s square root of 3 plus s square root of 4 plus s square root of 6 over s square root of 1 plus s square root of 3 plus s square root of 8. But where should we start the solution? To solve this, I'm going to start with this number, 4. 4 can be written as the product of two numbers, 2 and 2. 6 can be written as the product of two numbers, 3 and 2. Also, 8 can be written as the product of 4 and 2. So, here we go. Welcome to Maths with Teacher MJ. In this video, I'm going to solve this fun little math problem. But before I start the solution, please feel free, pause the video, solve it yourself, then compare your answers with my solution. Remember, if you use different way to solve this question, let me know. It always makes me happy to see how creative you guys can be. Now I'm going to start the solution after 2 seconds. 1, 2, go ahead and get started. To solve this, I'm going to first let this expression equals x. So what is x? X is going to be s square root of 2 plus s square root of 3 plus 4 can be written as a product of 2 and 2. So it's going to be s square root of 2 times 2 plus 6 product of 3 and 2. So it's going to be s square root of 3 times 2 over s square root of 1 is 1 plus s square root of 3 plus 8 can be written as the product of 4 and 2. So it's going to be s square root of 4 times 2. To continue the solution, I'm going to get help from a math rule that says s square root of ab is same as s square root of a times s square root of b. So let's see what is x. S square root of 2 plus s square root of 3 plus s square root of 2 times 2 can be written as the product of s square root of 2 times s square root of 2. So it is going to be s square root of 2 times s square root of 2 plus this one s square root of 3 times s square root of 2 over 1 plus s square root of 3 plus s square root of 4 times s square root of 2. But what is the next step? Look, if we have this step and this step, how can we continue the solution? To continue this solution, I'm going to continue my work, my solution by working on this step. Here we have s square root of 2 times s square root of 2. Here we have s square root of 3 times s square root of 2. What is the common factor between this term and this term? Right, s square root of 2 is the common factor between this term and this term. So we can factor s square root of 2 out of this expression. So it's going to be, I want to write this, s square root of 2 plus s square root of 3. This one is going to be s square root of 2. S square root of 2 times s square root of 2 divided by s square root of 2 is going to be s square root of 2 plus s square root of 3 times s square root of 2 divided by s square root of 2 is going to be s square root of 3 over 1 plus s square root of 3 plus, as you know, 4 is a perfect square, so s square root of 4 is 2. So it's going to be 2 square root of 2. But what is the next step? X is going to be, look, here one term, here one term. What is the common factor between this one and this one? Right, s square root of 2 plus s square root of 3. Also here we have s square root of 2 plus s square root of 3. So I'm going to factor s square root of 2 plus s square root of 3 from both terms. It is going to be s square root of 2 plus s square root of 3 factored out. The first term divided by this is going to be 1 plus this one divided by s square root of 2 plus s square root of 3 is s square root of 2 over. Now here we have 1 plus s square root of 3. But what is 2s square root of 2? Let's see. 2s square root of 2 is same as s square root of 2 plus s square root of 2, right? S square root of 2 plus s square root of 2 is 2 square root of 2. So I write here plus s square root of 2 plus s square root of 2. So until here we did it well. Let's continue the solution. Let me erase this part. To continue the solution, watch it. Here we have x. S square root of 2 plus s square root of 3 times 1 plus s square root of 2. Here we have 1 plus s square root of 3 plus s square root of 2 plus s square root of 2. Now I'm going to get help from this rule that says a plus b is same as b plus a. We can do this when we add two terms together. So here, instead of s square root of 2 plus s square root of 3, I want to write s square root of 3 plus s square root of 2. Later, you will see why I do this. X is going to be s square root of 3 plus s square root of 2 times s square root of 1. Here we have 1 plus s square root of 2. I will write s square root of 2 plus 1. Open. What do we have here? 1 plus s square root of 3 plus s square root of 2 plus s square root of 2. I will write this one first. S square root of 3. Second, s square root of 2. Next, s square root of 2. And last one, 1. Now, let's see what do we have here. Okay. Top s square root of 3 plus s square root of 2 times s square root of 2 plus 1. Here, what do we have? Again, denominator, we have s square root of 3 plus s square root of 2 plus s square root of 2 plus 1. So what should we do to continue the solution? To continue the solution, I'm going to let a equals s square root of 3 plus s square root of 2. How about this one? I'm going to let b equals s square root of 2 plus 1. Let's see what is x. So x is going to be, this one is a times this one b over this one a, this one b. So x is going to be ab over a plus b. So what is the next step? What can we do to continue the solution? If x is ab over a plus b, I can write 1 over x is a plus b over ab. Right? X is ab over a plus b. So what is 1 over x? 1 over x can be written as a plus b over a b. But what is this? Let's see. We have 1 over x is a plus b over ab. But as you know, this is same as a over ab plus b over ab. Is this correct or not? Absolutely yes. Look, a plus b over a is same denominator. So we can write the denominator and add numerator. A plus b over ab. But what is this? This a and this a can be cancelled off. And this b and this b can be cancelled off. So 1 over x is going to be 1 over b plus 1 over a. This is same as 1 over a plus 1 over b. So 1 over x is 1 over a plus 1 over b. Let's see, what is 1 over x? 1 over x is 1 over a. I want to write a is, where is a? S square root of 3 plus s square root of 2. S square root of 3 plus s square root of 2 plus 1 over b. What is b? b is s square root of 2 plus 1. But how can we continue the solution? To continue the solution, I need work on this one and this one. Let's set this one as x, set this one as y, and see what is x and what is y. Wait. Let me erase this part. We need more of this. So, x is 1 over s square root of 3 plus s square root of 2. To solve this, I am going to multiply both top and bottom by conjugate of denominator. But what is conjugate of s square root of 3 plus s square root of 2? Conjugate of s square root of 3 plus s square root of 2 is s square root of 3 minus s square root of 2. S square root of 3 minus s square root of 2. So it's going to be s square root of 1 times this s square root of 3 minus s square root of 2, s square root of 3 plus s square root of 2 times s square root of 3 minus s square root of 2. What is this? A plus b times a minus b can be written as first term s squared minus second term s squared. So s square root of 3 plus s square root of 2 times s square root of 3 minus s square root of 2 can be written as s square root of 3 s squared minus s square root of 2 s squared. So let me write. So x is gonna be s square root of 3 minus s square root of 2 times s square root of 3 s squared minus s square root of 2 s squared. Top s square root of 3 minus s square root of 2. S square root of 3, s squared is 3. S square root of 2, s squared is 2. 3 minus 2 is 1. So the answer is s square root of 3 minus s square root of 2. This is our x. But what is y? Y is 1 over s square root of 2 plus 1. Again, to continue the solution, I am going to multiply both top and bottom by conjugate of denominator, which means s square root of 2 minus 1, s square root of 2 minus 1. So it's going to be s square root of 2 minus 1, a plus b times a minus b is going to be a squared minus b squared. So a squared between s square root of 2s squared or 2. 1 squared, which means 1. So y is going to be s squared of 2 minus 1. Until here we did well. Good job. So 1 over x, let me find a place. I wanna erase this part. 1 over x is going to be this x, which means s square root of 3 minus s square root of 2 plus y, which means this way. We are saying y is s square root of 2 minus 1. But what is this? Let me write it. 1 over x is s square root of 3 minus s square root of 2 plus s square root of 2 minus 1. This negative s square root of 2 and this positive s square root of 2 cancel off. So 1 over x is going to be s square root of 3 minus 1. Until here we did it well. Keep it here. This is 1 over x, but we need to find out the value of x. This is 1 over x. So what should we do? we have 1 over x equals s square root of 3 minus 1. So what is x? X is 1 over s square root of 3 minus 1. How can we simplify this one? Multiply both top and bottom by conjugate of denominator, which means s square root of 3 plus 1, s square root of 3 plus 1. On top we have 1 times s square root of 3 plus 1. On bottom we have s square root of 3 plus 1 times s square root of 3 minus 1. What is this? S square root of 3 plus 1 times s square root of 3 minus 1 is same as s square root of 3. S squared minus 1 s squared. So x is going to be s square root of 3 plus 1 over s square root of 3 to the power of 2 is 3. 1 to the power of 3 is 1, which means s square root of 3 minus 1 over 3 minus 1 is 2. So our answer, or x, is going to be s square root of 3 minus 1 over 2. And this is the most simplified answer of our question. Have fun.